It really is the perfect analogy. And, well, it's great to be here with you all to talk about this. Because in an age of just massive information overload, where we expect high-definition photos of everything instantly, Neptune really stands as a masterclass in human deduction.
It really does.
It shows us how much we can understand about a world nearly 3 billion miles away through sheer critical thinking, physics, and mathematics, long before we ever actually got a clear picture of it.
So our mission today is to pull back the curtain on this extremely bizarre world. We're talking about a planet that challenges our understanding of fluid dynamics, extreme weather, and honestly, how solar systems even form in the first place.
Yeah, it breaks a lot of rules.
It really does. But before we can dive into the sheer chaos going on inside Neptune, we have to talk about that hidden room. Like, how did humanity actually manage to find a dark, distant world that is completely invisible to the naked eye?
Well, it's basically a cosmic detective story where gravity left the fingerprints. But the ultimate irony here, and this is my favorite part, is that the greatest visual astronomer of his time actually looked right at it and just didn't realize what he was seeing.
Wait, you're talking about Galileo, right?
I am, yeah.
Because according to our sources, Galileo actually spotted Neptune in his telescope way back in 1612, and then he literally drew it again in his notes in 1613.
He did.
Okay, let's unpack this. How does the absolute legend of the telescope just, miss an entire planet?
I know, it sounds crazy, but it really comes down to terrible timing and the mechanics of orbits. So when Galileo observed Neptune, it happened to be very close to Jupiter in the night sky.
Which gave him a reason to look in that direction.
Exactly. But more importantly, Neptune was in its retrograde cycle. So from Earth's perspective, it appeared almost perfectly stationary for weeks at a time.
Oh, wow.
Yeah. So Galileo noted it, but he reasonably assumed it was just a fixed background star.
Right, because for anyone trying to visualize this retrograde illusion, think about the last time you were driving on a highway in a fast car and you passed a slower moving car in the lane next to you.
Well, that's a good way to look at it.
Yeah, because for a brief moment as you pull alongside and pass them, the slower car looks like it's sitting completely still or even moving backward relative to your window.
Right, the relative motion cancels out.
Exactly. Earth was doing that to Neptune. We were zooming past it on the inside track of the solar system, making this incredibly distant, slow-moving giant look like just a static point of light.
Spot on. And because Galileo's telescope was, relatively rudimentary, and Neptune's apparent motion was so slight due to its massive distance, the planet's true nature stayed hidden for over 200 more years.
200 years?
Yeah. The real breakthrough didn't come from looking through a better lens. It came from looking at numbers.
Okay, so how did we go from a telescope miss to finally finding it? The source material mentions a French astronomer named Alexis Bouvard in 1821.
Yes, Bouvard.
And he was mapping out the orbit of Uranus, which was, at the time, the outermost known planet. But Uranus wasn't following the schedule, was it?
Not at all. I mean, it wasn't behaving the way Isaac Newton's laws of gravity dictated it should. It was speeding up and slowing down at all the wrong times in its orbit. So Bouvard looked at these deviations and hypothesized that there had to be an unseen gravitational perturber out there in the dark, physically tugging on Uranus.
The draft in the hallway.
Exactly, the draft.
But how does that actually work mechanically? I mean, how does an invisible thing make a planet speed up and slow down?
Well, imagine Uranus and this invisible mystery planet are both running on a circular track. But Uranus is on the inner lane and moving faster.
Okay, I'm picturing it.
So as Uranus approaches the mystery planet from behind, the gravity of that unseen giant pulls Uranus forward, right? It speeds it up.
Makes sense.
But once Uranus passes it and pulls ahead, that same gravity is now pulling backward on Uranus, slowing it down. Bouvard saw this exact pattern of acceleration and deceleration in the data.
That is just brilliant. So fast forward to the 1840s, and we have two mathematicians, John Couch Adams in England and Urbain Le Verrier in France.
Right, and they were working completely independently of each other.
Yes, completely independently. And they both decide to tackle this mathematical nightmare. I mean, they have to reverse engineer the mass and the exact location of a planet that no one has ever seen, purely based on how badly Uranus was wobbling.
It's known as an inverse perturbation problem. And honestly, doing it by hand in the 1840s was a monumental feat of calculation.
Without computers.
No computers at all. So Le Verrier finally finishes his math in 1846. He sends a letter to an astronomer in Berlin named Johann Gottfried Galle, basically saying, point your telescope at this exact patch of sky.
And Gall actually listens to him.
He does. Gall gets the letter on September 23, points his telescope, and within 1 degree of Leverrier's mathematical prediction, boom, there is Neptune.
That is staggering. The fact that math can be that precise is just wild. Though I read this sparked a massive, really intense nationalistic rivalry between the French and the British over who really deserved the credit for the discovery.
Oh, absolutely. It was a huge point of pride for both nations.
Yeah.
But, stepping back from the politics, this discovery was an absolute triumph for Newtonian physics.
Because it proved the math works everywhere.
Yes. It proved that the laws of gravity applied consistently and predictably, even at the darkest, coldest edges of the solar system.
So the math worked perfectly to give us a location. But equations on a piece of paper in 1846 couldn't possibly prepare us for the bizarre, extreme environment hiding beneath those blue clouds.
No, they really couldn't.
Yeah.
Which brings us to the physical reality of the planet itself. And this is where things start to just defy our everyday common sense.
Let's get into it, because here is where it gets really interesting. Neptune is 17 times the mass of Earth, and we always hear it called an ice giant, a category it shares with Uranus.
Right, ice giants.
But I have to admit, when I hear ice giant, my brain immediately pictures a giant, solid, frozen snowball drifting through space. But our sources make it clear that is incredibly misleading.
It is a bit of a misnomer, yeah.
Yeah.
At least based on how we use the word ice in everyday life.
Because it's not actual ice cubes.
Right. In planetary science, the term icy is actually a specific convention. It's used to describe a mixture of heavier volatile elements, specifically water, ammonia, and methane.
Okay, so it's a chemical label.
Exactly. This distinguishes them from the lighter hydrogen and helium gases that make up gas giants like Jupiter and Saturn.
So it's not a snowball at all. If anything, trying to picture the inside of a pressure cooker is way more accurate for Neptune.
Much more accurate.
Yeah.
Because beneath its outer atmosphere, Neptune doesn't even have a solid surface you could stand on.
None at all.
None. As you descend, the gas transitions seamlessly into this slushy, electrically conductive layer. This mantle makes up about 10 to 15 Earth masses, and it is a hot, dense, supercritical fluid.
I want to hover on that concept for a second, because supercritical fluid is one of those terms that sounds cool but is really hard to wrap your head around.
It is tricky to visualize.
Yeah, it basically means the pressure and temperature are so extreme that the physical distinction between a liquid and a gas just ceases to exist. It's this crushing, boiling soup.
That's exactly what it is.
And because of those extreme pressures, specifically at around 7,000 kilometers deep, the chemistry inside Neptune does something that sounds like pure science fiction.
Oh, you're talking about the diamond rain.
Literal diamond rain. But wait, how is that actually happening? There aren't just diamonds floating in space that get sucked in, right?
Right, no. It's a chemical transformation driven by extreme forces. That supercritical mantle is really rich in methane. And a methane molecule is just one carbon atom bonded to 4 hydrogen atoms.
Okay, basic chemistry.
Yeah. But as you sink deeper into Neptune, the crushing pressure and the intense heat physically break those chemical bonds. The hydrogen is just stripped away,
Leaving the carbon.
leaving the loose carbon atoms. And they are then squeezed together so tightly that they bond into crystal lattices.
They turn into diamonds.
Precisely. And because diamonds are denser than the surrounding fluid, they literally rain down through the mantle toward the core, like incredibly dense hailstones.
That is wild, just falling through a boiling ocean. And it goes even deeper than that, doesn't it?
Oh, it gets weirder.
Yeah, because according to high-pressure experiments conducted here on Earth, scientists believe that at the very base of the mantle, right on top of Neptune's core, there might be an entire ocean of liquid carbon.
Yes, a liquid carbon ocean.
And those sinking diamonds don't melt. They remain solid and literally float in this liquid carbon ocean like icebergs.
Liquid carbon oceans and diamond icebergs, and it really stretches the imagination. And sitting at the center of all this is a solid core of rock and iron, roughly the mass of Earth, but burning at a blistering 5,400 Kelvin.
Which is roughly 5,100 degrees Celsius. I mean, that is basically as hot as the surface of our own sun, squeezed into the center of a planet at the absolute edge of the solar system.
It is, and that extreme temperature is crucial to understand because that immense internal heat doesn't just stay trapped down in the core, it naturally wants to escape.
Like a boiling pot.
Exactly, it convects or boils up toward the surface. And that upwelling heat is the engine that drives the most violent, chaotic weather in the entire solar system.
So let's trace that heat up into the atmosphere, because this is where the visual chaos really starts. NASA's Voyager 2 spacecraft flew by Neptune in August 1989. And by the way, it remains the only spacecraft to ever visit the planet.
The only one, yeah.
It sent back images of this incredibly deep, vibrant blue world. But it wasn't a serene blue marble. The winds on Neptune hit speeds of up to 2,100 kilometers per hour. That's 1,300 miles per hour.
Which actually exceeds supersonic flow. It's faster than the speed of sound in Neptune's atmosphere.
That is just terrifying. How does wind even get moving that fast?
Well, part of it is the lack of friction. Unlike Earth, Neptune has no mountains or solid surface to slow the winds down.
Oh, right. There's nothing for the wind to hit.
Exactly. But the main driver is the massive temperature gradient. The intense heat from the core is bubbling up, meeting the freezing cold temperatures of the upper atmosphere.
Creating a huge contrast.
Right. That contrast creates massive convection currents that get whipped into a frenzy by the planet's rapid rotation.
And those winds create some massive storms. Voyager 2 observed this huge anticyclonic storm roughly the size of Earth, which they called the Great Dark Spot. It looked a lot like Jupiter's famous Great Red Spot.
It really did. Now, on Earth, an anticyclone is usually a high-pressure system that brings clear, sunny weather.
Right, nice weather.
But on Neptune, these high-pressure anticyclonic storms act like massive atmospheric mountains. They push the surrounding air up, which clears away the white upper clouds and exposes the darker, deeper layers of the atmosphere underneath.
Which is why it looks like a dark hole.
That's exactly why it looks like a dark hole.
But the craziest part about the Great Dark Spot is that when astronomers pointed the Hubble Space Telescope at Neptune just 5 years later, in 1994, it was completely gone. Just vanished.
Dissipated entirely. But the thing is, new dark spots had already appeared in other latitudes.
So the weather is just constantly churning.
Yeah, it showed us that Neptune's atmosphere is wildly dynamic and completely unstable, which is a stark contrast to its planetary neighbor Uranus, which can look almost entirely featureless and blank for really long stretches of time.
Wait a minute, though. Let's think about this logically. Uranus is closer to the sun. Neptune is 50% further away from the sun than Uranus is.
Yeah.
In fact, it receives only about 40% of the sunlight that Uranus gets. So if Neptune is sitting out there in the freezing dark, nearly 3 billion miles away, where is it getting the energy to sustain a more active atmosphere than Uranus?
Now, that energy imbalance is one of the great mysteries of the outer solar system, because the data shows that Neptune actually radiates 2.61 times as much energy into space as it receives from the sun.
So it's basically acting like its own space heater.
What's fascinating here is that it's highly likely this heat is primordial. It's left over from the massive collisions and gravitational collapse during the planet's original formation, 4.5 billion years ago.
Wow, it just held on to it all this time.
Yeah. Neptune managed to hold on to its internal heat much better than Uranus did. And that deep churning heat source is what powers those Earth-sized storms.
But the sun isn't totally irrelevant out there, is it? I mean, even from that immense distance.
Oh, not at all. In fact, a study published in 2023 made a startling discovery about Neptune's atmosphere using decades of data from the Hubble Space Telescope.
Oh, about the clouds.
Yes. Scientists realized that Neptune's high-altitude cirrus clouds, which usually streak across the planet, had completely vanished.
And the immediate assumption you'd make is, oh, it must just be winter on Neptune, because Neptune takes 165 Earth years to orbit the sun, meaning a single season lasts about 40 Earth years.
Right, that would be the logical guess.
But it wasn't a seasonal change, was it?
No, the timing didn't line up with the seasons at all. The disappearance of the clouds was actually linked directly to the 11-year solar cycle.
The sun's magnetic cycle.
Exactly. The sun naturally goes through periods of high and low magnetic activity, and when the sun is highly active, it emits a lot more ultraviolet radiation.
And that UV radiation travels all the way out to Neptune. But wait, how does sunlight physically create a cloud?
It's a photochemical reaction. Think of the UV light as a molecular hammer. When it hits the methane molecules high in Neptune's atmosphere, it literally smashes them apart.
Breaking the bonds again.
Right. Those broken pieces then recombine into complex hydrocarbons, which condense into the white, hazy ice clouds we see.
So it's basically a solar-powered chemical factory in the sky.
That's a perfect way to describe it.
So when the sun quieted down during its solar minimum, the factory shut down and the clouds on Neptune just faded away. That is an incredible display of cause and effect spanning 4.5 billion kilometers.
It really is. It proves that even at the very edge of the solar system, the sun is still completely pulling the strings on planetary weather.
Unbelievable. So we have a planet with a boiling core, diamond hailstorms, and supersonic winds driven by leftover creation heat and solar radiation.
A lot of extreme conditions.
Yeah. But if you think the weather is chaotic, Neptune's magnetic field and its collection of moons are just completely broken.
Broken is definitely a good word for it. Neptune's magnetosphere is structurally bizarre.
Let me try to give a visual for this for anyone listening. Imagine a child's spinning top spinning perfectly upright in the middle of a table.
Okay, standard top.
Yeah, that's how you expect a planet's magnetic field to align straight up and down with its rotation. Now imagine you smack that top so it leans way over to the side and you push it completely off the center of the table.
Right.
That's Neptune. Its magnetic field is tilted 47 degrees away from its rotational axis, and it's physically offset from the center of the planet by over 13,000 kilometers.
It's completely lopsided. And because of this asymmetrical geometry, Neptune's auroras, its version of the Northern Lights, which the James Webb Space Telescope actually recently captured, glowing beautifully. They don't happen at the poles like they do here on Earth.
Where do they happen?
They happen randomly around the planet's mid-latitudes.
But why is it so off-center? Earth's magnetic field comes from our molten iron core. Does Neptune's core just, not work right?
Well, that's the leading theory. Planetary scientists believe Neptune's magnetic field isn't generated in the deep central core at all.
Wait, really? Where is it coming from then?
Instead, it acts like a broken dynamo. The magnetic field is likely being generated much closer to the surface, inside a thin spherical shell of that electrically conducting slushy water ammonia fluid we talked about earlier.
Oh, the supercritical fluid.
Yes. And because it's being generated in a churning outer layer rather than a stable center, the field is wildly unstable and misaligned.
Wow. The chaos just drips through every single layer of this planet. And it definitely doesn't stop at the magnetic field. Let's look at its moons.
Oh, the moons are fascinating.
Right, so Neptune has 16 known moons, but one of them absolutely dominates the entire system. Triton. Triton makes up 99.5% of all the mass orbiting Neptune.
Almost all of it.
But Triton is doing something that fundamentally breaks the rules of planetary formation. It is orbiting backward.
Yes, it has a retrograde orbit. It moves in the exact opposite direction of Neptune's rotation. And mathematically, a retrograde orbit tells a very clear, very violent story.
Because things that form together spin together.
Exactly. It proves that Triton could not have formed alongside Neptune from the same primordial disk of dust and gas.
So if it formed from the same swirling cloud, it would be swirling in the same direction, so it's a kidnapped moon.
Without a doubt, Triton was almost certainly a dwarf planet originally residing in the Kuiper Belt, which is the ring of icy bodies out beyond Neptune.
So think of a world very similar to Pluto.
It's exactly like Pluto. At some point, early in the solar system's history, Triton wandered too close and was gravitationally captured by Neptune.
And when you drop an object the size of Pluto into an existing, well-ordered system of moons, but you send it flying in the wrong direction, I mean, that is going to be a demolition derby.
Oh, it would have been absolutely catastrophic. Triton's sudden, massive gravitational presence going the wrong way through traffic likely scattered, collided with, or completely destroyed Neptune's original system of moons.
It just wrecked the neighborhood.
Totally. It either ground them to dust or ejected them into deep space entirely.
So Triton is essentially the lone survivor of a massacre it caused itself?
That's one way to look at it, yeah.
But this kidnapping story has a built-in ticking clock. Triton isn't going to get away scot-free. Because it's orbiting backward, the tidal friction between Triton and Neptune is actually stealing orbital energy from the moon.
It's slowing it down.
Right. It's causing Triton to slowly, inevitably spiral inward toward the planet.
That's true. It's on a slow death spiral. In about 3.6 billion years, Triton will cross a boundary called the Roche limit.
Okay, can you break down the Roche limit for us? What actually happens physically when it crosses that line?
Sure. So the Roche limit is a critical distance based on gravity. As Triton gets closer, the gravitational pull from Neptune on the near side of the moon becomes significantly stronger than the pull on the far side of the moon.
So the front is being pulled harder than the back.
Exactly.
Yeah.
And when it crosses the Roche limit, that difference in gravitational pull becomes stronger than the physical forces holding the solid moon together. Yes, it will be completely shredded into pieces.
Man.
A feeling of a draft, as you said. It's a lot to take in. But I think the most important thing you can take away from all of this is a profound sense of scale and honestly remaining wonder.
Yeah.
Because in a modern world where we feel like we have all the information right at our fingertips, Neptune proves how much wild, untamed mystery is still sitting right in our own cosmic backyard. We have to remember Voyager 2 flew past it for just a few hours in 1989.
And that's it.
That is the only time humanity has ever been there. The James Webb and Hubble telescopes are doing amazing deductive work from afar, but Neptune is really just waiting for the next dedicated probe to truly unlock its secrets. It's a long time, but it's coming. No, it won't. Which would be incredible.